Hello friends, once again most welcome in this series of prediction of important questions. And now I am starting with chapter number 14, dual nature of radiation and matter. Actually there is no need of important questions for this chapter. If you start studying it, you can finish it within a time span of 1 hour. I guarantee you. Because there is one small experiment is there. In a vacuum tube, there is one window through which light radiation is incident on a emitter plate, and due to this intensity, if this intensity of light is greater, or if ultraviolet light incident, then there is emission of photoelectrons. Okay, this experiment is, please try to understand the core part of this experiment. But important part is what? Frequency. Its graph. We know that if the frequency of incident light is greater than certain minimum value, that means if the frequency is equal to or greater than threshold frequency, then and then only there is photoelectric emission. That graph is very important. Next is intensity graph, variation of intensity, and third part. This part is very crucial. There will be one question. Potential. With the variation in the potential, photoelectric current varies. Here, emission of photoelectrons is not because of the potential difference applied. If we reduce potential to zero, still photoelectric current flows. And when this potential is decreased below zero, that means if it is negative potential, at one particular value of negative potential, photoelectric current stops. Here we come to know that the flow of electron is just because of what? Kinetic energy. And that kinetic energy is equal to work done by stopping potential. Graph of kinetic energy. Those intersect in the graph are very important. Small questions will be there or MCQ will be there. And important part for the numericals is de Broglie. Lambda is equal to h by p, or lambda is equal to h by mv. Okay. Or we have different expressions. Lambda is equal to h by under root 2 mevs, or lambda is equal to h upon under root 2m kinetic energy. Or in short, for MCQ, lambda is equal to 12.27 divided by square root of potential, but this answer will be in angstrom unit. All the numericals are based on this expression and Einstein's photoelectric equation. That equation is very, very important. Photoelectric work function, energy, Planck's quantum theory, E is equal to h nu is equal to 5 plus kinetic energy. You can find kinetic energy, or you can find photoelectric work function, or you can find total energy. All these numericals are based on this part only. And one more small part for theory is properties of matter waves. This much is there. Do this much part only. This is sufficient. Okay? Thank you.